Hello students, so today we are going to learn about electricity. Now what is electricity? Generally we say that electricity is flow of electric current, or in more appropriate way we can say flow of electric charges. Okay, so first of all, consider about this atom. This is a atom, and this atom is having three subatomic particles. You know about that? Electron, proton, and neutron. Electron, proton, and neutron. Electron is having negative charge, proton is having positive charge, and neutron is finally no charge. It is neutral. And proton and neutron stays at the center of atom, and it is known as nucleus. It is known as nucleus. There are so many orbits or shells present in an atom. You know that they are known as KLM. There are actually 7 shells: KLM, N, O, P, Q. Okay, so you studied about only 3 shells in your previous classes. So we are writing about 3 shells, KLM. So M is outermost shell. Now there are so many electrons. First shell is having 2, and second is having 8, and last one can have different numbers. Okay, 1 2 3 4 5 6 7 8. Okay, so this is outermost shell, and it is having only one atom, one electron. Okay, so there are basically 2 types of electron. First category, all of the electrons can be included in first categories, that they can orbit in their they can rotate in their particular orbits. These are their orbits, and they can rotate. They can take a circulatory motion, and they can rotate in their particular orbit. This electron will move in this, and this will in particular this will move in K, this is L, and this will move in M. Okay, there could be more than 3 shells, maximum 7 shells. So the electrons of outermost shell, okay, I'm talking about outermost. So first category, so the first category of types of electrons, all electrons can be included in this category, that all of the electrons can move in their corresponding shells. But the second category includes only those electrons which are present on outermost shell, and it can move out from its atom. This electron can move out from its atom. Okay, this electron can move out from atom. You heard correct thing. Okay, if the shell N, if the shell can be N, then it comes out from N. It can be O, then it will comes out from O. It can be K, it can comes out from K. It can be L, it can comes out from L. But the we can say the promising condition should be that the electron is present in outermost shell, and the electrons which are present in outermost shell are known as valence electron, or electrons depends upon the number of electron. Okay, so here I'm talking about only the electron which is present in outermost shell. It could be 2 3 1 2 3 electron. Okay, electron. Okay, this is valence electron. Now what is the condition, or what can we do to move it away or to release it from its atom? We have to use a particular and appropriate amount of force, and this force is known as, have you heard about some forces known as tidal force, solar? Okay, you have heard about tidal energy, solar energy, and very important energy, that is wind energy. Okay, so if anyhow you are made to produce some force by rotating windmill, or by using tide, or by using sun, you are anyhow make you are able to make a force. Okay, now I'm making the force. Okay, I made the force and I applied this force to this atom. And by the help of this force, or by the impact of this force, the electron will finally release out. Okay, with its charge, that is negative charge. And negative charge, the symbol of charge is Q. Okay, Coulomb. Okay, so electron will come out with its charge Coulomb. Electron will come out with its negative charge, that is Coulomb. Suppose you are studying this and in future years you think that I can make energy, so what can you do? You have to develop some method, or you have to develop some any device, so that you can make a force other than these conditions. Okay, you can make force other than these conditions. Okay, and when you make this force and you apply to this atom, random atom, and this force is applicable or very perfect force, that it will help to release this electron out, or it can make this electron out from its atom. It will come out, so you will be able to make another source of energy, another source of electricity. You can sell it in market. You will be a millionaire. You can do it according to your hard work or whatever your brain works. Okay, so the need is to make a force by using anything. You can use anything, and force should be appropriate, applicable for a particular aptitude to particular magnitude. Okay, particular magnitude, to make this atom to release its electron outside. Okay, now this is the key point what we have studied: flow of electric charge. Now suppose this is a copper wire. It is having millions of electron atom, and each and every atom has electron in its outer shell. Now you provided a force. Okay, and this force able this electron with its charge, I am denoting charge by a dot, it allows this electron to comes out. Okay, now the condition for this metal is, this is a random matter, you can consider copper or anything, that only one electron or only two electron or only three electron can remain in its outermost shell. There is a condition for every metal, that only a particular amount of number of electrons can remain in its outermost shell. So now we are providing force here, and this force helps this electron to come out from its atom. Now this electron come out and electron stay here. Okay, now the condition is what was the condition? That this particular atom can allow only one atom in its outermost shell. Now this electron remain here, and this electron goes here and finally here. Okay, now condition, again this condition. Okay, only one atom can remain in its outermost shell. Now it will remain here because it is forceful, it have force, we gave it force, because of force it will remain here, and this will go here and it will stay here. So this movement of electron, okay, movement of electron is occurring. Okay, but but with the help of electric charge, because electron is not alone. We know that electron is having negative charge, we know Coulomb. So here electron is moving from one atom to another atom, one atom to another atom, one atom to another atom, by the help of force. Okay, if you will generate force in future, kindly inform me. Okay, jokes apart. So it will move, and electron is moving with its charge. It is known as Coulomb. So let's back to our definition: flow of electric charges. Okay, so what is moving? A charge, negative charge is moving along with electron, and it is making a current. it is making a current and flow, it is making a flow of current, or it is making flow of electric charge. So not only it is moving electron, it is also moving charge with it, and this is our electricity. Let's go for this. Look how electrons are moving. Look how electrons are moving from one to another. You can see this, how they are moving. Look, this is here, then this is here, then this is here. Okay, again here, here, or so finally the condition that what we studied, that only one electron or only two or only three, depends upon the type of substance, and it should be metal. Okay, because metals can give off their electrons easily, so only one, they go, and they also carry the negative charge. So electricity is flow of electric current or electric charges. Which charges is flowing? Negative charges flowing. Okay, which is also known as Coulomb.